Let us continue exercise 13B, question number 24. There is a water flowing at the rate of 2.52 km per hour through a cylindrical pipe into a cylindrical tank. From a cylindrical pipe into a cylindrical tank. Then the radius of the base is 40 cm. So if there is the increase in the level of water tank in half an hour, 3.15 meter, find the internal diameter of the pipe. If you see here, we have kilometer per hour, here we have centimeter, here we have meter. All are in different unit. So first of all, we have to convert them to proper unit. So let us convert them first. So first thing, we have 40 centimeter. Let's convert it to meter. We know 1 meter equal to 100 centimeter. So to convert meter into centimeter into meter, we have to divide by 100. 40 divided by 100, 0, we get 0.4 meter. Then next, height of the water in the tank, it is equal to 3.15. Already in meter, so no problem. Radius of the pipe we don't know, so we write it R. Then next, the rate of flowing is given to be 2.52 kilometer. Again, we need to convert to meter. So 1 kilometer, we know it is 1000 meter. So we multiply with 1000 meter, then 2 number after decimal, 20 we can cancel. So now it is equal to 252. Then remember, they say that the volume of the water from the cylindrical pipe, it flow into cylindrical tank. That means whatever volume we have in the cylindrical pipe, it will be equal to the volume in the cylindrical tank. We have the water flowing from the pipe into the tank. It takes half an hour. So we can write that volume of water in tank, it is equal to volume of water in the pipe in half an hour. So the cylindrical dimension, so the volume will be formula for volume of cylinder, that is equal to pi r square h. Then here they say volume half an hour, so we'll take 1/2 volume of the pipe in the volume of water in the pipe, so that is still a cylinder, pi r square h. So if you see from both sides, pi common, we can cancel. Capital R we know 0.4, then h we know 3.15, then 1/2 remains same, R we don't know, h we know 2520. So we want to find r square. This one which is down, cross multiply up, the one which is up, bring it down. So let us try to cancel it. So here if you go with 2, then 1260, okay, with this, then again with 2, here we have with 5 into 2, 5 into 5, 5 into 2, then here we have 5 because 5 is less than greater than 3, so we go directly with decimal, becomes 63. Then in order to remove the decimal, we have 1 2 3 4, we can put 0 down. Then 63 divide here, we get 4 cancel, so we want only r, we put square root. Square root of 4 will be 2, square root of this 1000 will be 100, so 2 divided by 100 equal to 0.02 meter. So that is why that is the radius. So the pipe will be, diameter will be double, it will be 2 into 0.02, which is equal to 0.04. Continue to 25. We have hemispherical bowl. So there is a hemisphere whose internal radius is 9 cm. Here we have full of water. Then what happened? That water is emptied into cylinder. So here you see, first the water is put into the hemisphere. So we'll take the shape of hemisphere. Then we pour it into the shape of cylinder. So we'll take the shape of cylinder. So that means the height and the radius will different, but the volume of the water will be same, because we don't increase, we don't decrease the volume, we only change the shape. So that means the volume of the water in the hemispherical bowl equal to volume of water in cylindrical vessels. Using that fact, we can find the height of the water. According to the question, volume of water in hemisphere equal to volume of water cylindrical vessel. So we replace formula. Volume of hemisphere 2 by 3 pi r cubed. Volume of cylinder pi r square h. Pi common from both sides, we can cancel. 2 by 3 remain. R we know it is 9. So 9 into 9 to 9. Capital R 6 into 6 into 8. Then 3 divide 9 here 3. Then we want h, so this is multiply, you take the side, become divide. So 2 divide 3, 3 cancel, 3 divide 2, 3. So 3 into 9, 27, divide by 2, which is equal to 13.5. So the height of the water in the cylinder will be 13.5. We get what the question want. Then next we will move on to the next question. What they say, there is a hemisphere tank, it is full of water. Then from there it is empty by a pipe at the rate of 27 by 5 by 7 liter per second. So we need the time for this water to pass through, okay, till it will take to empty half of the tank. So remember, because the water take the shape of the place where it is put, so it will take the shape of hemisphere. So, and we know that in this hemisphere full of water, so in order to get the volume of water, we have to get the volume of hemisphere. Then after that we have to see how much it is empty to half of it, okay, by the pipe whose diameter is given to be 3 meter at the rate of 25 by 7 liter only for 1 second. The diameter from the hemisphere tank is 3 m. Radius will be 1.5 m. So the volume of the water in the tank will be volume of hemisphere, that is 2 by 3 pi r cube. 2 by 3 remain. Pi we know 22 by 7. R we have 1.5. Since we have power 3, we can multiply it 3 times. Then 3 we divide here, 0.5. Then we multiply 2 into 22 into 0.5 into 1.5 into 1.5, we get 49.5. We divide with 7. So when we divide, we get 7.07 meter cubed. So now, because here we have to empty it per liter, so we need to convert the value from meter to liter. We know 1 meter cube equal to 1000 liter, so we need to convert it. So if we multiply by 1000, we get 7070 liter. Then remember, we have to empty half of the tank, so that means we divide by 2. It will be equal to 3535 liter. Now we need to find the time to empty this 3535 liter. So it's given for 1 second, it will take 25 by 7 liter to empty. Okay, so those. So for 25 by 7 liter, time taken is 1 second. Then if it is for 1 liter, the time will be less. So it will be 1. Then into 7 we take up, 25 we bring down. Then now we need for this much, so the time will be more. So we do this one with this one, multiply this. So 7 into this one, we divide by 25. So the approximate time needed will be 9898 in second. Okay, those.